This is where BMW motorcycles are born, right here at the Berlin plant in Germany. You are currently viewing the engine crankshaft manufacturing process. In today's exclusive video, you'll see the production of BMW motorcycles from the Adventure, Boxer Roadster, and Sport model series. Right now, you're watching the main factory of BMW's motorcycle division, called BMW Motorrad, which in German means motorcycle. This BMW employee uses a special, small camera to inspect the quality of the machined hole in the crankshaft. BMW crankshafts are typically made from forged steel or cast iron, depending on the engine type and performance requirements. Forged steel crankshafts are commonly used in high-performance and modern engines, such as those in the M series or turbocharged models. They are typically made from forged carbon steel, often enhanced with micro-alloying elements, such as in 4340 steel or similar high-strength alloys. Cast iron crankshafts, typically made from nodular iron, are used in lower performance or economy engines. They're cheaper to produce and durable enough for engines with lower stress demands. The crankshaft is one of the most critical components in a motorcycle engine, converting the reciprocating motion of the pistons into rotational motion that powers the bike. Material is carefully selected for fatigue resistance, torsional strength, and heat tolerance, as it must withstand high RPMs and engine stresses. The raw steel is forged under high pressure to form the basic shape of the crankshaft. This process aligns the metal's grain structure, enhancing strength and durability. The initial forging outlines key features like the main journals, crankpins, and counterweights. The forged crankshaft then undergoes CNC rough machining to remove excess material and bring it closer to its final dimensions. Key features like the main journals, rod journals, and counterweights begin to take shape, though tolerances remain relatively loose compared to the final precision requirements. Next, the crankshaft undergoes heat treatment, typically quenching and tempering to increase its hardness and enhance fatigue resistance. Now you can see the processing and preparation of the connecting rods. The connecting rod is a critical component of any motorcycle engine. It connects the piston to the crankshaft, converting the piston's reciprocating motion into the crankshaft's rotational motion. As of the latest available data, this factory employs approximately 2,400 individuals and has the capacity to manufacture up to 900 motorcycles daily. This Berlin plant has a rich history, having been operational since 1969. Over the decades, it has produced over 1.8 million motorcycles. Engine production is a central and highly automated process. Approximately 560 engines are assembled daily, equating to about 120,000 engines per year. This includes various engine types such as the iconic Boxer twin, inline engines, and smaller single-cylinder units. There are 6 engine assembly lines, 5 for petrol engines and 1 for electric motors. These lines are equipped with 21 robotic cells to assist in handling and assembly, ensuring efficiency and precision. Each engine undergoes a comprehensive assembly process, typically taking about 2 hours, which includes multiple testing stations to ensure quality and performance. Depending on the engine type, the assembly process ranges from 90 to 250 minutes. For instance, assembling a Boxer engine typically takes about 90 to 130 minutes, while an inline 6-cylinder engine may require up to 150 minutes. These skilled technicians perform critical tasks such as installing pistons, bearings, and pre-assembled cylinder heads. These manual operations are complemented by automated stations that assist with belt drives, cable installations, and other components. The engine assembly takes place in a dedicated area within the plant known as the Engine Assembly Hall. This facility is equipped with state-of-the-art technologies and is staffed by approximately 300 engine specialists working in 2 shifts. Additionally, the plant's mechanical production building produces up to 4,000 engine parts per day using advanced machinery and techniques. Motorcycles produced here are exported to over 130 countries, underscoring the plant's pivotal role in BMW Motorrad's global operations. BMW Group Plant Berlin serves as the lead facility for global motorcycle manufacturing, overseeing assembly operations in Brazil, Thailand, and China. Spanning nearly 220,000 square meters, the plant is one of the largest industrial employers in Berlin and a significant contributor to the city's industrial heritage. As you can see right now, the engine is taking its final shape. Employees are tightening bolts using pneumatic wrenches suspended from the ceiling of the factory hall. The exact conditions for tightening all bolts or applying the best oil inside the engine are predetermined and must be absolutely identical for every engine. BMW uses high-quality materials, precise manufacturing techniques, and rigorous quality control. This leads to long-lasting engines, smooth operation, and minimal mechanical issues. BMW has over 100 years of motorcycle experience. They have a strong racing and endurance heritage, which influences performance and reliability in road bikes. BMW Motorrad achieved a record-breaking sales performance in 2023, delivering 209,257 motorcycles and scooters, marking a 3.1% increase from the previous year and setting the highest sales volume in the company's history. The strongest sales region was Europe, with 118,700 units sold, representing about 56% of global sales. Germany led the European market with 26,100 units, followed by France with 20,600 units, Italy with 16,600 units, and Spain with 13,000 units. In the United States, BMW maintained its position as a key market, selling 17,200 units, marking a slight increase compared to the previous year. The BMW S1000 led the supersport category with 11,610 units sold, keeping its top position in the market. The BMW F Series made a significant contribution with 40,800 units sold. The BMW G310 series sold a total of 22,339 units, showing BMW's strong presence in the entry-level segment. With 209,000 units sold, BMW Motorrad holds a 0.4% share of the global motorcycle market, positioning it as a prominent player in the premium segment. Honda leads the global market with 19.4 million units sold, capturing approximately 39% of the market share. Two camshafts have now been installed in the engine. This engine has a double overhead camshaft, called DOHC valve system. One camshaft operates the intake valves and the other operates the exhaust valves. Each cylinder has 4 valves, for a total of 16 valves. The pair of camshafts allows precise valve control, higher engine speeds, and improved performance. At the end of the entire manufacturing process, the engines undergo testing. This includes functional tests, performance evaluations, and inspections to detect any potential defects or deviations from specifications. These BMW employees in blue work overalls have meetings several times a month. They serve as team-building sessions, but also for assigning tasks and discussing improvements to the production process. Only about 8% of BMW Motorrad's workforce are women. Very few of them work on the assembly lines, with most employed in the finance department and in quality control. Now you're watching BMW motorcycle parts being painted. This is the paint shop at the Berlin plant. Before painting, parts go through a multi-stage cleaning process like degreasing, rinsing, and surface activation. This ensures that paint adheres properly and the surface is perfectly smooth. This Berlin plant is where nearly all BMW motorcycles are painted. Every single GS, R, S, K, and M series bike passes through this paint shop. Robot arms apply primer, base coat, and clear coat with microscopic accuracy. They ensure the same thickness of paint across every part, which is impossible to achieve consistently by hand. Robots can maneuver spray guns at precise angles to reach edges, curves, and tight spaces. Robots eliminate human variation, so every GS or S 1000RR tank comes out identical in color tone and gloss. This guarantees color matching across different parts. Robots can work 24/7 without fatigue, increasing output. They use optimized spray patterns that minimize overspray, which saves paint and reduces waste. Many metal parts receive an electrostatic dip coating. The part is dipped in a bath, and paint particles are attracted to the metal using electricity, creating a uniform corrosion-resistant base layer. Now, skilled factory workers, often called pinstripers, apply the finishing touches with a fine brush dipped in special enamel paint. They paint freehand without stencils or guides, relying purely on steady hands and years of practice. Each stripe or line is unique, Small variations prove it's handcrafted. BMW Motorrad frequently releases special paint schemes. The paint shop handles these limited run designs with the same precision as standard colors. After painting, every part is visually inspected under special lighting to catch even the smallest defects. Only flawless parts move on to final assembly. In the case of orders, for example, for the German police force, the required markings are applied to the motorcycles at the end of the painting process. In this case, this worker is applying the Polizei lettering. The Bavarian police have adopted the latest generation of BMW motorcycles, such as the BMW R1250, for their operations. More than 80,000 BMW motorcycles are currently in official use in over 150 countries, including Germany. Right now, you're watching the final assembly and installation of the pistons into the engine block and cylinder. This R1200GS boxer engine is built through a careful process that combines machines and skilled workers. The boxer engine assembly is a hybrid process, combining robotic precision with skilled human craftsmanship. Robots take care of precise tasks like shaping the cylinder head and installing valve seats, which helps maintain consistent quality and speed. At the same time, experienced technicians handle important steps, such as putting on the cylinder head, adjusting valve timing, and running final tests to make sure the engine meets BMW's high standards. This mix of automation and hands-on work shows BMW's focus on quality and innovation in how they build their motorcycles. The R1200GS engine is a 1,170 cubic centimeters, air-liquid cooled, 4-valve per-cylinder boxer twin. Notably, it was the first BMW Motorrad engine to utilize a glycol coolant mixture, enhancing thermal efficiency and performance. The aluminum crankcase halves are first cleaned and checked to make sure their dimensions are accurate. Then, CNC machines may be used to drill and shape areas like the bearing seats and oil passages with high precision. This helps ensure everything lines up correctly for the engine's moving parts. The forged crankshaft is installed into the crankcase with main bearings. Technicians use torque-controlled pneumatic tools and sometimes measure clearances with feeler gauges to ensure precision. Crankshaft balance is verified to reduce vibration and increase longevity. Forged pistons with rings are carefully inserted into cylinder barrels. Each cylinder is lined and honed to exact specifications before assembly. Cylinders are then mounted to the crankcase, with technicians checking for perfect sealing and alignment. Oil pump, water pump, and cooling passages are installed. BMW uses a combined air and liquid cooling system for optimal engine performance. Flow tests ensure no leaks and proper circulation. Parts like the starter motor, alternator, and intake manifold are installed first. Then, wiring harnesses and sensors for the engine management system are connected. Finally, the fuel injection system is installed and carefully calibrated. Each engine goes through dimensional checks, torque checks, and leak tests at every stage. Precision instruments measure clearances, tolerances, and rotational smoothness. Any deviation triggers a stop and inspect procedure, ensuring zero defect quality. Completed engines are usually tested on a bench to check things like compression, oil pressure, smooth idling, and the function of electronic sensors. This testing simulates real-world conditions to make sure everything works properly before the engine is installed in a motorcycle. Robots take care of tasks that require exact repeatability, such as drilling and milling the crankcase halves, machining valve seats and cylinder bores, and installing bearings in precise positions. This level of automation ensures micron-level accuracy, which is essential for the engine's durability and smooth performance. Robots assist with lifting heavy components like crankshafts or cylinder barrels into place. This reduces strain on workers and prevents potential misalignments caused by manual handling. Right now, you're watching a worker testing the performance of a fully assembled engine. Computers check the engine's power output and smooth operation at maximum RPM. After passing all tests, engines are cleaned, coated with protective oil, and sent to the motorcycle assembly line. Once the engine is ready with all parts painted and all other motorcycle components delivered, the main assembly line can finally start. The entire assembly line is very much like a giant puzzle. All the motorcycle parts are put together in a predetermined sequence, resulting in a complete and fully functional motorcycle. This main assembly line is where all motorcycle subcomponents come together: engine, frame, suspension, electronics, bodywork, and paint. Engines and painted parts arrive from their preparation areas and are brought to the assembly line, which follows a specific order. First, the frame and chassis are assembled, then the engine is installed. After that, the suspension and wheels are added, followed by the electrical systems and wiring, the fuel system, brakes, and handlebars. Finally, body panels and painted parts are fitted. Throughout the process, workers and robots work together in a coordinated effort to make sure every component is installed correctly. Robots handle repetitive, precise, or heavy tasks like bolting and fastening engine and chassis parts, lifting heavy components into place, and assisting with torque-controlled assembly operations. Humans perform essential tasks such as installing electrical wiring and sensors, making final adjustments to brakes, suspension, and valves, applying hand-painted details and custom finishes, and carrying out quality inspections and troubleshooting. The assembly line handles both standard models and special editions, including custom features like unique paint jobs, police or military modifications, and limited edition badges and pinstripes. Human craftsmanship plays a key role in this process to ensure BMW's premium quality is maintained. BMW upholds zero defect standards by thoroughly checking components at every stage. This includes verifying alignment and torques, testing wiring and electronic systems, and ensuring smooth operation of the engine, brakes, and suspension. You are now watching a motorcycle being tested on a dynamometer. Dynamometers, or dynos, are used to measure engine and motorcycle performance under controlled conditions. Some inspection points use computerized monitoring, while others depend on skilled technicians performing visual and manual checks. Before leaving the assembly line, each motorcycle goes through engine test runs, brake tests, suspension checks, and electrical system verification. Only motorcycles that pass all these tests proceed to packaging and shipping. The assembly line is designed like a giant puzzle, where each step depends on the previous one. Synchronization between parts delivery, engine assembly, and painting ensures no bottlenecks. BMW can assemble dozens of motorcycles per day, depending on model complexity. Exhaust gases are collected and filtered to meet environmental regulations. Noise levels are controlled to protect workers during testing. Only motorcycles that pass dyno testing move on to road testing, where applicable, and final delivery. This guarantees that each bike leaving the Berlin plant is fully functional, safe, and performs as expected. Quality inspectors work according to a predefined checklist, checking dozens of details on each motorcycle. Several different models are assembled on the same assembly line at the same time. Thanks to advanced planning, this is not a problem. Workers in this factory operate in well-coordinated teams. At each workstation, there are usually 2 workers, with one of them responsible for the final quality of the tasks performed. Right now, you're watching how they have a stock of many screws ready and automatically assemble the final body parts. Motorcycles move across the assembly hall on suspended yellow holders. This keeps them elevated so workers don't have to bend down and can easily work at eye level. At the end of the assembly line, the motorcycles are connected to diagnostics. And while running, the engine's operation and proper connection of all systems are checked again. Most motorcycles at BMW factories are built as modular machines. This approach makes servicing and repairs easier to do at home. BMW motorcycles are highly popular among bikers, especially for their reliability, comfort, and long-distance touring capability. You are now witnessing the very start of the assembly process for the iconic BMW S1000RR motorcycle, where precision and craftsmanship come together to bring this high-performance machine to life. The BMW Motorrad plant in Berlin-Spandau serves as the central production hub for the BMW S1000RR. This facility has been manufacturing motorcycles since 1969 and is renowned for producing high-performance models, including the S1000RR Superbike. BMW has been building motorcycles there since 1969, and the S1000 is assembled alongside other BMW motorcycles in a highly modernized section of the facility. Although many components, particularly the engine and keyframe elements, are carefully hand-assembled by skilled technicians, Robotic automation guarantees precision in welding, painting, and testing. The assembly line seamlessly combines German engineering tradition with cutting-edge Industry 4.0 technology, including AI-assisted quality control and real-time diagnostics. The full assembly of a single S1000 takes about 1 to 2 working days, depending on the specs. The engine assembly itself is a highly intricate process that takes several hours, with multiple precision checks conducted at every stage. Each motorcycle can be custom-built to the customer's specifications, including color, performance packages, electronics, and more, through BMW's order system. This customization is handled right on the main line, with modular assembly stations that adapt based on order configurations. The S1000RR is exported worldwide from Berlin, with certain markets, such as the US, Japan, and Australia, receiving special editions featuring localized components, including emission systems and lighting. This motorcycle extensively utilizes lightweight aluminum and carbon fiber reinforced plastics, reducing weight while preserving structural rigidity. The engine internals also use titanium valves and forged pistons for strength and high revving performance. The 999 cubic centimeter inline-4 engine is engineered with exceptionally tight tolerances, enabling it to reach exhilarating revs of up to 14,500 RPM, while delivering precise performance and reliability. It's assembled in a clean room-style environment, and parts like the crankshaft, camshaft, and cylinder head are made in-house. The electronics suite, including dynamic traction control, cornering ABS, quick shifter, and the 6.5-inch TFT screen interface. It is developed by BMW engineers in close coordination with the hardware team. The bike receives firmware updates just like a smartphone or a car via BMW dealers. Last year, the BMW S1000RR maintained its market dominance, securing the top spot in the supersport category with 11,610 units sold. The S1000RR saw a 13% increase in sales last year, evidence of its continued popularity. Since its launch, the US has been one of BMW's strongest markets for the S1000RR, consistently topping sales charts and leading the brand's lineup. Japan, Canada, and Australia also see strong demand, with models tailored to meet regional specifications. While specific sales figures for the BMW S1000RR in Europe are not publicly disclosed, it was among the brand's top-performing models. Full motorcycle assembly began at this plant in 1969, starting with models such as the R60/2 and the /5 series. As of the latest available data, the BMW Motorrad plant in Berlin-Spandau employs approximately 2,400 workers. Germany, production workers at BMW typically earn between $29,700 to $31,900 per year. The plant also includes a training center with apprenticeship programs to educate future technicians. According to BMW's official information, the Berlin Spandau plant produces up to 800 motorcycles daily across various segments, including sport, tour, roadster, heritage, adventure, and urban mobility. Contributes significantly to BMW Motorrad's global output, which surpassed 210,000 units last year. Components fit within micrometer tolerances, 1/10 the width of a human hair. Up to 2,000 connecting rods are produced each day and sorted by weight to ensure perfect balance. About 110 crankshafts are machined per shift with an accuracy of 0.00004 inches. The aluminum bridge frame, which weighs about 24 pounds, is attached to the engine block. Before final assembly, the front forks, suspension, and wiring harnesses are installed. All bolts and assembly steps are tracked electronically to make sure everything is done correctly. Each bike is tested on a roller dynamometer to check the brakes, clutch lights, and overall performance. A dynamometer simulates real-world riding conditions while the motorcycle is stationary. Each engine undergoes a cold test on a dynamometer that simulates fuel intake and exhaust flow. Finally, the bikes are filled with oil, brake fluid, and fuel, and the last parts like fairings, mirrors, and windshields are put on. Each engine takes about 120 minutes to assemble, with up to 140 engines built per day. On the production line, one motorcycle is assembled every 65 seconds. The S1000RR Superbike is made up of over 4,500 individual parts. When fully fueled, the S1000RR weighs around 440 pounds. It produces a maximum torque of 83 pound-feet and has an engine output of 199 horsepower. Each fully assembled engine is connected to 8 measuring lines to monitor airflow in the cylinders and other critical parameters. Experienced riders can detect subtle issues through the seat of their pants, ensuring human judgment complements automated measurements. Every assembly station tracks bolt tightening, component installation, and torque electronically. Each component, fairings, fuel tanks, etc., has a barcode or chip, ensuring its origin and installation are traceable. Bikes that fail any test step are flagged for special treatment until corrected. During dyno testing, the S1000RR experiences track-level speeds and performance stresses, ensuring your superbike has already been put through its paces before ever hitting public roads. This K1600 GT, along with the GTL, was first shown in July 2010 and went on sale in March 2011. It was made to replace the K1300 GT and give BMW riders a strong 6-cylinder option for touring. Engineered and built entirely at BMW Motorrad's Berlin Spandau facility, the main hub for nearly all K-Series production. The plant handles every step of production, from engine machining and frame welding to painting and final assembly. Inline-6 units like the K1600s are built in a clean, controlled environment, using automated aids alongside skilled technicians. Engines are suspended on the yellow C-hooks and assembled together with the frame, suspension, wheels, and fairings. Panels are painted by robots in a clean booth, while decorative details, like the striping on the K1600, are still applied manually by skilled workers. These are the opinions of some owners of these beautiful machines. Very pointy front end, very confidence-inspiring into corners. Quick shifter and blipper were imperceptible. Great TFT and options. Cruise control, loved it. The final quality control department tests the performance and craftsmanship of each machine. The engine's build quality and its performance parameters are the main strengths of these powerful motorcycles. Now that the motorcycles are finished and polished, it's time for packaging and preparation for export to dealerships and their future owners. The motorcycle is placed in a reinforced metal frame, often supported with wooden slats for stability. Tear-resistant film is applied over the frame and bike to protect it from scratches and dust during transport. Labeling and barcodes are attached for identification, tracking, and destination information. Before shipment, a last visual and technical inspection is performed. Technicians check that all components are secured, fluids are at the correct levels, and the bike is roadworthy. Each bike is tracked digitally to ensure it reaches the correct destination without mix-ups. Here's how the BMW R12G/S comes together at BMW's Berlin Spandau plant. The BMW R12G/S is a modern reinterpretation of the iconic R80G/S, blending classic enduro design with contemporary technology. Introduced in 2025, this bike is assembled at BMW's Berlin Spandau plant, continuing the legacy of the GS series. Each R12G/S is powered by a 1,170 cubic centimeter air/oil-cooled boxer engine, delivering 80 kilowatts at 7,000 revolutions per minute and 115 newton meters at 6,500 revolutions per minute. The bike features a one-piece tubular bridge steel space frame with a bolted-on rear frame, optimized for off-road ergonomics. Equipped with a 21-inch front wheel and a 17-inch rear wheel as standard, the R12GS offers superior off-road capability. Components such as the cockpit fairing, fuel tank, and seat are installed, followed by comprehensive quality checks. As of now, specific production figures for the R12G/S are not publicly disclosed. However, given the high demand and the plant's capacity, it's expected that production numbers will be substantial. Flat solo seat with multiple height options for optimal off-road riding posture.